Well, what do we have in store for us today? Unit 4, Day 6. Solve using the quadratic formula. We're going to be doing the quadratic formula today. Fun. But before we begin, let's simplify the following. That's what we're going to do. Looking in the numerator, looks like we have a radical that can be reduced. Let's see what that reduces to. 216. Ding, ding, ding. We hit a perfect square. We can stop right there. Hey, that rhymes. All right. So let me pick up where we somewhat left off. Here we have -4 plus the square root of 32 reduces to 4 root 2 all over 2. Once you have fully simplified the radical, which we have, you then want to check, are all of these outside numbers divisible by a common number? And they are. They're all divisible by 2. So if we divided every single one of these outside numbers by 2, we'd be left with -2 plus 2 root 2 all over 1, but the 1's not needed. In fact, you will never see it. 1 plus 2 root 2. There's your final answer. Example 2 is more or less the same, so let's take a look at example 3 where it's a little bit different. This time we're taking the square root of a negative number. Let's start by reducing this bad boy. There, left over. All right, so this simplifies to -5 plus 3i root 5 all over 10. Since it's a negative root, we have to, well, make it positive once we simplify and put an I in front. Then we check, are all of the outside terms divisible by a number other than 1? And no, they're not. So we're going to leave our answer just like this. And now example 4. Ooh, this one's a little bit different. Well, first of all, we're dealing with a perfect square. And we have a plus or minus symbol. Plus or minus the square root of 9 is 3 all over 5. What this pretty much means, y'all, is that we have 2 different answers that we need to simplify here. I need to do 6 plus 3 over 5, and we need to do 6 minus 3 over 5. That's what that plus or minus means. 6 plus 3 is 9. That will not reduce. 6 minus 3, -3. And this will not reduce. Those are your final answers. You have now learned 2 ways to solve a quadratic equation. List them. Well, one of them is factoring, and the other one's the square root method. Today, we're going to learn a third method. Looking at example A, if we had to solve this by factoring, we would do A times C, number in front times number in back. That gives us -21. And the factors of 21 that subtract to get -4 are 3 and 7. In this scenario, we need 3 to be positive and 7 to be negative. This is factorable. Your factors are x plus 3, x minus 7. And if you set each of these equal to 0 and solve, you'd get -3 and you'd get positive 7. Okay, so those are your answers for example A. Example B, number in front times number in back, or A times C. These are all of the factors of 10. We need the factors of 10 that add to get 8. Oh my gosh, none of these work. Here's what that means. That means you cannot solve this by factoring. You would have to use the quadratic equation. That quadratic formula is here. Make sure you have that memorized. I am not entirely certain that that information will be given to you on a test. Hopefully you have it memorized by now. But if not, do it. All right, let's move over to the next side of our notes. Example C, we have x squared minus 8x plus 10 equals 0. This is the exact same problem we just left off on. We're going to have to use a quadratic equation to solve this. And in order to do so, you have to be able to identify your a, your b, and your c value. The a value is the number in front of x squared, which is 1 for us. B is the number in front of x, which is -8. And your c value is the number without an x, 10. And now we're going to use the quadratic equation, which is -b. It starts -b. or sometimes I like to say opposite b, opposite b. Our b value is -8. So opposite b would be +8. Plus or minus the square root of b squared. Make sure you put this number in parentheses. That does matter. -4 times a times c, all divided by 2 times a. Now we're going to start simplifying. 8 plus or minus square root. -8 times -8 is +64. All over 2 times 1 is 2. Now if you, let's see, 8 plus or minus the square root. If you did this math here that's inside the root, we have 64 minus 40. 64 minus 40. And 64 minus 40 is 20. All over 2. Now, before we move on, I'm going to point something out very important. This number inside the square root, once we have gotten to this point here where we did all of the math, and we've gotten to this point, this is known as the discriminant. And the discriminant tells you how many solutions you're going to have and what type of solutions they are, either real, complex, rational, or irrational. If this number is positive, that means you're going to have 2 roots. You will have 2 solutions, and they will be real. If it's, however, not a perfect square, that means they're going to be irrational. So if I just move my notes back here, type, they're real. They're irrational. In the number, we are going to have 2 solutions when everything is said and done. Okay, let's pick back up where we left off. The square root of 20 will reduce. 2 and 10. 2 and 5. Here's what it reduces to. 8 plus or minus 2 root 5 all over 2. Now that the root is fully reduced, check and see, are all of these outside numbers divisible by a common term? And they are. We can divide them all by 2, leaving us with our final answer of 4 plus or minus root 5. We have 2 solutions, and they happen to be real and irrational. Looking at example D, well, first notice that they don't have it in the correct order. It's not set equal to 0. So you would first have to add 5 to both sides of your equation. And if you do so correctly, this is where we're currently at. Our A value here is 2. B value is 5. C value also 5. Now let's start plugging into the quadratic equation, starting with opposite B, plus or minus square root of B squared minus 4 times A times C all over 2 times A. Let's start simplifying. -5 plus or minus. All of this simplifies to -15 all over 4. Okay, let's take a look at what our discriminant is. Our discriminant is -15. That tells us the type of solutions that we're going to have. If that number inside the root is negative, that means you are going to have 2 solutions, but they are going to be complex. They are going to be imaginary. So 2 complex solutions. Let's see. The square root of 15 will not reduce any further, but the square root of -15 will just a little bit. So it looks like our final answer is going to be -5 plus or minus I root 15 all over 4. Taking a look at example E, looks like this one is also not set equal to 0, so make sure you subtract 4 from both sides of the equal sign, which would then have our equation at 0, and if you do so correctly, this is where we should be. Our A value here is 6. Our B value is -1. Our C value is -2. Let's use the quadratic equation. Opposite B plus or minus square root B squared minus 4 times A times C all over 2 times A. Now let's start simplifying. 1 plus or minus, all of this reduces to the square root of 49 over 2 times 6, which is 12. If that number is positive, that means we are going to have 2 real solutions. And if it's a perfect square, which it is, that means they're going to be rational. 2 real rational solutions. That's what your discriminant tells you. Make sure you're aware of not only how to use the quadratic equation, of course, but also how do you find the discriminant and what does that tell you? Let's simplify. We have 1 plus or minus the square root of 49 is 7 all over 12. And now we have 2 problems that we have to simplify. We have to simplify 1 plus 7 over 12 and 1 minus 7 over 12. 1 plus 7 is 8 over 12, and 8 over 12 is going to reduce to 3 over 4. Is that right? Why does that seem funny to me? No, 2 over 3. No, that's not right. Yeah, that's not correct. It simplifies a 2 over 3. Sorry about that, y'all. 2 over 3. It simplifies a 2 over 3. I thought that was a little weird. Okay, over here, 1 minus 7 is negative 6 over 12. And this is going to reduce to negative 1 over 2. So those are our solutions. They are real and they are rational. And there's 2 of them. Okay, you've seen me do a few of these. Let's do one more together before we get to the word problem there. Let's take a look at example 3. Our A value here is 1. Our B value is 4. Our C value is 5. Let's get going. Opposite B, plus or minus square root of B squared minus 4 times A times C all over 2 times A. Negative 4 plus or minus the square root of. If you simplify all of this, it is going to reduce to negative 4. If we simplify a little bit further, we have negative 4 plus or minus. The square root of 4 is 2, and the square root of negative 4 is 2i, all over 2. Now that we have fully simplified the root, check and see if these numbers are divisible by a common number. And they are. They are all divisible by 2, leaving us with our final answer of negative 2 plus or minus I. And one thing I forgot to mention is that since this discriminant is negative, that tells us we have 2 complex solutions or 2 imaginary solutions. And now example G, let's take a look at the word problem. A vacant rectangular lot is being turned into a community vegetable garden measuring 8 meters by 12 meters. A path of uniform width is to surround the garden. If the area of the lot is 140 square meters, find the width of the path surrounding the garden. Well, we know that the dimensions of our rectangular garden are 8 by 12. And then we know that the area surrounding the garden is of uniform width, meaning it's the exact same length. So that means from here to here is X amount of space. From here to here is X amount of space. From here to here, X amount of space. From here to here, X amount of space. So here's our new dimensions. Our new width is X plus 8 plus X. That's our new width. And that can simplify a little bit further, of course, to 2X plus 8. Put those in parentheses. Now, if we did the same thing here, we'd get 12 plus X, which is 2x plus 12. And we're going to set that equal to what our area is, because remember, width times length equals area. Well, we know the area is 140. Now we're going to go ahead and FOIL these sets of parentheses, 2x times 2x, 2x times 12, 8 times 2x, 8 times 12. Let's now combine our like terms, and we also need to subtract 140 and bring it over here, setting the equation equal to 0. Now listen, everybody. Yes, we've been doing the quadratic equation today, but that doesn't mean you're always going to have to use a quadratic equation to solve one. I would try not to use the quadratic equation if you don't have to. Let's see if this can factor. What I notice about every single one of these terms in our trinomial is that they're all divisible by 4. So I'm going to start by factoring out a 4. Now I'm going to check to see if what's in parentheses, what I have left over, if that's factorable or not. A times C. These are the factors of 11. They have to subtract to get 10, which they do, meaning we don't have to use the quadratic equation. Also, since our leading coefficient in the parentheses is a positive number, then that means we can go straight to factored form. X minus 1, x plus 11, set that equal to 0, and don't forget we had that 4 in front of our problem also. Now that we have all of our factors, you want to set all your factors equal to 0. 4 equals 0. No, it doesn't. That's not going to give us an answer. X minus 1 equals 0. That can be solved. X equals 1. X plus 11 equals 0. That can be solved. X equals negative 11. Now we're dealing with width here. They wanted to know, find the width of the path surrounding the garden. If we simply solve for X, we have our answer, which we have done. But we're dealing with length, width, dimensions. So we don't want the negative result. We want the positive result. Here, your answer is 1. Have a good day, everybody.